All right, so you've made it to Unit 1, Lesson 7. This lesson is the last lesson in Unit 1. So after this, you are going to be doing some sort of study guide or review or both, and then we will be taking our unit test on lessons 1 through 7. Make sure that you are checking over, making sure that you have all the notes, all the practicing, all the checkpoints before you can take that unit test. So this last lesson concerns absolute value equations and inequalities. This video is just going to concern absolute value equations, right? Because I know we covered some of them in Algebra 1, but this is a sticky subject, so I'm going to take some extra time actually on this lesson to make sure that we're all kind of on the same page. So, absolute value, what I want you to understand is that absolute value is not just positive, okay? Absolute value is a number's distance from 0. So the absolute value of something will always be positive, but the only reason that is because it is a distance. So any distance we talk about, unless it's below sea level, we're going to talk about distances being positive numbers. So this key concept kind of goes over that the distance between a number and 0 is its absolute value. When we start shifting things around, you see that with the equations. So I'm going to jump right to example 1, and we are going to solve this absolute value equation. So the idea is whatever's inside this absolute value, whatever value it is, we don't know what it is yet because we don't know what x is, but we know that it's 6 units away from 0. So what I'm going to do is I'm going to set up 2 equations, and those equations are going to represent the 2 numbers that are 6 away from 0. So the first number that's 6 away from 0 that I can think of is just simply 6. The other number that's 6 units away from 0 is -6. So with these absolute value equations, you're always setting up 2 separate equations, all right? So if it's set equal to 6, our absolute value equations will be x minus 3 could be 6, x minus 3 could be -6. So there are 2 solutions to this this equation, Getting ahead of myself. So solving the first equation, add 3 to both sides, x is 9. All right, x is 9. Then, solving this next one, add 3 to both sides, x is -3. And it seems a little weird, but these both satisfy this equation. And I can test that really quick by plugging in 9 for x. Absolute value of 9 minus 3. 9 minus 3 is 6. Absolute value of 6 is 6. So that checks out. As for -3, -3 minus 3 is -6. The absolute value of -6 is 6. So that checks out too. So that's a good way to just check. Plug the number back in, evaluate it. So you just evaluate it by taking care of what's inside the absolute value and ensuring that the absolute value is equal to your solution. So usually I start off this lesson with guided practice 1. But I still want you guys to work through it, see if you can solve them. If you can't, ask for help. But then again, try to work them out. You know that the answers are coming up. So good time to pause the video. In 5 seconds, probably, I'm going to show you the answers, my worked out solutions. Okay, so here are your solutions to the guided practice. Number 1, pretty straightforward. Our absolute value can be 5, or the absolute value inside of it could be 5 or -5. So what I'm saying there is, if I plug in 5, absolute value of 5 is 5. Absolute value of -5 is 5. So those 2 check out. We're just seeing what 2 numbers are 5 away from 0. Next one, set it up kind of like the first example. X minus 5 could be 2, x minus 5 could be -2. And I just solve those by adding 5 to both sides in both equations. Checking, 7 minus 5 is 2, absolute value of 2 is 2. Checking 3, 3 minus 5 is -2, absolute value of -2 is 2. So those check out. Your next example. The issue with this one, we've got variables on either side. So this one, this type of equation is very important for you to check your solutions. Very, very important, because a lot of times one solution will be valid, one will be invalid. We'll talk about what that means in a second. So, setting up my two equations. 4x plus 10, I'm going to set it equal to 6x. My other equation, 4x plus 10 is equal to negative 6x. So very, very similar to the equations we just solved, except I got variables on both sides. Because when we think about it, the result of inside that absolute value can be negative. But once we get out of value from that absolute value, it's going to be positive. It's a distance. So me solving this, first equation here, 4x plus 10 equals 6x. Subtract 4x. Subtract 4x. 10 equals 2x. X equals 5. And I'll check that solution at the end. I'll show you how to do that at the end. Other equation. Getting x on the same side, or x is on the same side. Subtract 4x. Subtract 4x. 10 equals negative 10x. X is negative 1. Okay? So, when we look at this, you just got to think kind of critically here. And I'm not even going to have to really solve the entire, or evaluate the entire solution, but I want to show it here, just to be thorough. So if I'm plugging in 5 to this inequality, that's going to be 5 times 4, which is 20. 20 plus 10 is 30. So absolute value of 30 equals 6 times 5, which is 30. So that's just the result of me doing some mental math, substituting in 5 and checking that as an answer. 5 checks out. That's good. I'm going to put a little check mark next to it saying, hey, that's good. Next, plugging in negative 1. Absolute value of negative 1 times 4 is negative 4. Negative 4 plus 10 is 6. So absolute value of 6 equals, on the right-hand side, 6 times negative 1 is negative 6. Well, absolute value of 6 can't be negative anyways. Absolute value of 6 is 6. So that solution is not valid. So really our actual solution to this equation is 5. Negative 1 is not a valid solution. So that is important to check. Very important to check. So again, guided practice, pause it, wait a few seconds. The solutions will show up. I will explain them. Make sure that you are doing these independently though. Don't just copy them down. That's not going to help you retain this. These are good self-check opportunities for you. Okay, so here you have it for the guided practice. Number 3, just setting it, my absolute value, the contents of it, equal to 11, equal to negative 11, and then solving those out. And again, you can check those by plugging those back in, evaluating them, and verifying that they're true. Okay. The real checking comes with number 4, because there are chances for what we call extraneous solutions, or I just call them invalid. They don't make any sense when you plug in. So I set this equal to 6x, negative 6x, subtracted 3x from both sides, and then divided whatever number was being multiplied by x. For the first equation, I got x is 6. Second equation, I got x is negative 2. Plugging those in to verify, x equals 6 was the only solution that was valid. I plug in 6. 3 times 6 is 18. 18 plus 18 is that 36 I got here. And 36, the absolute value of it, is equal to 36. Did the same process. Realized the absolute value of 12 is not equal to negative 12. So that's why that is not a valid solution. So make sure that you are checking those answers and verifying that they are in fact valid, okay? So that's important. So that concludes absolute value equations. It's important to get a little bit of practice on this before you move on to inequalities, because inequalities do get a little more tricky. So move on to that next step now.